Okay, this is the end of Unit 5. Doing 5.7 using congruent triangles. So, I have the stack of paper on top of everything. I probably shouldn't do that in case if the pen bleeds. We aren't learning like anything like actually new today. Everything's kind of, I'm not gonna say intuitive, but we're just gonna add a slight add-on to what we've been doing so far in proofs for this class, and it's called CPCTC. What does this stand for, you might be asking? It stands for corresponding parts of congruent triangles are congruent. Sounds like a whole lot of hoopla to me, but there's a real meaning behind this, and we will see that in a second once I actually write this out. Or at least like write the keynote of like what the heck this means. So keynote, I'm making a star in red. What does this mean? It means once you prove two triangles congruent with one of your shortcuts, then it's too bad I'm writing in red. Then I'll make this super big. Everything on those triangles are congruent. Yes. So this, I remember in class, in third hour, one of you guys asked, well, these two sides are congruent if we have a midpoint somewhere. And I said, no, they're not. We don't know or have enough information yet. Technically, they are congruent, but we can't say it yet. This is the moment where we can make it happen. With CPCTC. This is our moment. So I'm going to draw out a picture, and we're going to prove a statement, and hopefully that kind of gets everything like foundated, or we have that foundation built of like, oh, this is what it means. It is truly just adding on one extra step onto everything we've done so far. Like that is what this step is. So I'm going to draw out what we be working with today. We'll do two examples. One's a proof, one's like a half proof. So I'm gonna draw this triangle. We'll call this R, S, T, and Q. I'm gonna have some congruent marks right here. I'm gonna have congruent marks down here. And I'm going to say my givens. I'm given that angle QRT is congruent to angle SRT, and that I have angle QTR be congruent to angle STR. And my goal is to prove that, well, what segments? I want to prove that QT is congruent to ST. So, you might be asking, okay, we're doing proofs again. What's the big difference between this? The difference is because of what we are proving. Like, this is our difference. We're not proving triangle congruency. We're proving other parts that are congruent. But, heavy but, in order to prove this statement, we have to prove that the two triangles are congruent. If these two triangles are congruent, then that means every side and every angle are going to be congruent with each other. So we just have to prove that these two triangles are congruent. So what I do for you guys, I would like, we got color, hold on. I'll get a different color pencil. Red and orange is too similar. All right, I found a box of crayons instead. Crayons it is. A 24 pack of crayons. Actually, I used to draw a lot in college. I like using crayons better than colored pencils. I like the feel of crayons. Let's pick out, I don't know. Pick out green. And I like yellow. Yellow. No, yellow and green are too, dang it. Oh no. Oh wait, hold on. I see a good, I can't put the, I like this one. I think it's like a peachy color. Yeah. Wait, what is it? Apricot. Apricot. All right, we're going to color in our triangles just so we know what we're working with. I'm going to color in this one down here. Color it in. I know I'm working. I have this triangle right here because it's marked off. We have 3 sides. Remember, triangles have 3 sides. And then we have this triangle right here. I guess that's more skin tone. I don't see why that's apricot. All right. So I'm going to make a note right here. Before this, we need to prove triangle congruence. We have to prove triangle congruence before that, which means looking at my triangles, I need to find that triangle QTR is congruent to triangle STR. I need to have this before I can do that. So let's format our proof. Let's do the same thing as we've been doing recently in class where we just look at our figure first. I have angles already. I have 2 angles in specific, and they're pretty close to each other. If I had a side in the middle, then I'd be able to say angle, side, angle. So that would work. That's good. And looking at my 2 triangles and how I colored them, I see that on this segment right here, RT, that the green and the apricot colors are both lining up on the same line segment of RT. So that means RT is in both of these triangles. So I'm going to make that note. RT is in both triangles, which means that we can say that RT is congruent to RT by the reflexive property. So I'll make a congruent mark here. And it looks like I have angle, side, angle right now. So I can put angle right here. I'll put a side in here and I'll put an angle out here. I have angle, side, angle. Good. Now I can make everything. I can make my proof or set it up. It's going to be squished a little bit. Oh yeah, we write in small today. Okay. Let's write our givens. I'm writing sideways. Oh my goodness. All right. Angle QRT is congruent to angle SRT, and angle QTR is congruent to angle STR, and that was given to me. I also just found that RT is reflexive, so I got to put that in here. So RT is congruent to RT, and that is my reflexive property. And since I got angle, side, angle with how it looks, we go from angle to a side to an angle. I can say that my triangles QTR is congruent to, what's the other one? STR by angle, side, angle. Okay. This is what we've done for the last few days of doing like ASA, doing side, 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 angle, side, like all that stuff. That's what we've done for the last few days. With today, with doing CPCTC, since we got that these 2 triangles are congruent, we can now start making other I'll use a Sharpie. I don't think that's going to show up too well. Do I have a Sharpie in here? I have a green Sharpie. I guess it's like lima green. I can start making other congruent markings on my figure. Since I have congruent triangles, everything is congruent. So I can say that these two sides are congruent to each other. I can say that these angles over here are congruent. That's supposed to be 3 lines. And in specific of what I'm trying. Oh, I guess I already wrote it down. Oops. In specific, I already written it down, but I could say that these ones are congruent as well. I was thinking that I had to prove these congruent. Oh no, I already written them already congruent down at the bottom. Everything's congruent, so we can say that RT is congruent to ST. Since we have congruent triangles already, everything is congruent about these triangles. All sides, all angles. So we finish our statement. We proved this. I just proved that QT is congruent to ST. Now, what would I put here? CPCTC. Because that's the reason. All corresponding parts of a congruent triangle are congruent to each other. CPCTC. So, back it up. You need to decipher what triangles are what you're working with to prove triangle congruency. After that, then you can say that all parts are congruent. So you gotta still find the triangle congruency. You just gotta work with it. And then CPCTC. You will probably have examples like this. We'll get I'm gonna get another piece of paper out. We're gonna do one more example for today. Example 2. And I will draw out my figure first. Boom, boom, boom. I have one going down the middle. I'll have this already given to me. And J, L, M, K. And I want you to show why JM is congruent to ML. That's your goal. Yep, that's your goal. I want you to prove that. Show it to me, please. So, hold on. I had to take a sip of Diet Coke. All right. So, we're not going to do this in a proof. I'm going to list it out because you'll have problems like this in your homework. No, you might. I don't know. We'll see. I'm not going to fully make a 2-column for this. We're just going to work through it. The work that we do work through, like the work that we show, you can put it in a 2-column if you want. I'm not going to be specific about it right now. But the work that we're just about to do, it's basically making a proof. We're just not putting it into the 2-column. So I'm going to look and see what information I have right now. I have that JK and KL are congruent with each other, and that was given to me in my figure. Noticing that I have the triangles. Well, I have the 2 congruent marks. We're going to color in our triangles as well. I'm going to get a blue out. Blue and green this time. I don't like the apricot color, so we're going to use blue. Color in this triangle. Color in this one. We're going to color in each individual triangle that we have, that we're going to work with. So we got to prove that these 2 triangles are congruent. What triangles are here? We have triangle JKM and triangle LKM. We need to show that they are congruent. And then we can see why JM is congruent to ML. Maybe instead of show, it should have been explain. But who cares? It's too far in the past at this point. One thing that you should take note, you should notice the right angle right here. The bad part about writing in crayon is that it makes it harder to write on the actual figure. Because we have the right angle right here, I guess we'll pop it out. I'll make it like that. If we have the right angle right here, if we want to see what this angle is of JMK, like angle JMK, we need to find its linear pair, find its other angle value. Because it's on a straight line, which means that if I add this 90 degrees to this whatever angle over here, we'll get 180. Now, based off of looking at the 90 degrees, we could make a very big assumption on what that angle could be. That's a linear pair right here, which is 90 degrees. We just get another 90-degree box. So, that was because of a linear pair. So I'm going to sketch out what I just worked on. I noticed that angle LMK and angle JMK make a linear pair. Which we also know that this is 90 degrees. And that led me to saying that angle LMK is congruent to angle JMK by all right angles are congruent. Because right angles always equal 90 degrees. This is a right angle. All right angles are congruent. Good. This is why I was very adamant on like knowing vertical angles, linear pairs, alternate interior, reflexive. Stuff shows up a lot in this class. Okie dokie. So, one last thing that we need. We need to find one thing. Now, noticing what I have on this figure. I have a right angle. I'm working with a right triangle, by the way. There is a property that works with right triangles only, which is the hypotenuse leg. So what I have right now is the hypotenuse and right angles. I need to find a leg that's congruent. I'm trying to find these two down here, so my only option is KM. Notice that the segment KM is on both of these triangles. So, what I can do is say that these are congruent to each other. So, I'm going to write down my next step. KM is congruent to KM because it's on both of these triangles. I'll jot a note out on both triangles. And I know this, and my reason for this could be the reflexive property. Well, it is the reflexive property. And that is our three reasons. We just proved triangle congruency for JK, M, and MLK. No, LKM, not MLK. MLK is this way. So I'm going to make a note so I can say that triangle JKM is congruent to triangle LKM by hypotenuse leg. And then because of this, we can say, I'm going to put these three dots. This means therefore. I don't want to write therefore. Therefore, JM is congruent to ML by CPC/TC. Gotta find the triangle, then you can use this. I'd make the note at the bottom of your paper for that one. You have to find the triangle congruence before using CPC/TC. And that's it. Like, this is the same process as what you've done for the last, 5 days or something in class. Not too different from what we've done already. And this is what the proofs will be like on your test. I'm 90% sure you will not be asked to prove triangle congruency. You'll be asked to prove a segment or something, or angles. Your final answer should be CPC/TC. But you still have to know your angle, like your congruency shortcuts. Like hypotenuse leg, side, 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 side angle, side, ASA and AAS. You have to know those still because you use those to get to this point. This is just a tiny little add-on, which means that everything in the triangle is going to be congruent. That's it for this one. That's the end of the unit. Woohoo!